Hi everyone. This lecture will be about the third type of high voltage, which is high voltage DC. In this lecture, we will understand the applications of high voltage DC and how to generate this type of voltage. First, let's see the applications of high voltage DC. The first application, high voltage DC, is mainly required in research work in the area of applied physics. It can be used in accelerators or electron microscopy. The third, high voltage DC can be used for testing equipment or insulator related to high voltage DC transmission system. If high voltage DC transmission system is used, so the insulator or the equipment in power system is subjected to high voltage DC. So we should generate high voltage DC in our lab to test the insulator under this type of voltage. Also, it's needed in insulation tests on high voltage AC power cables and capacitors. As we know, as the large capacitance of these power cables would take too large current if tested with AC high voltage. So, it's preferable to test power cables with DC voltage, since no charging current or capacitive current can flow in case of DC voltage testing. Also, high voltage DC is used in electromedical equipment like X-rays generators. High voltage DC is also used in industrial applications like precipitations and filtering of exhaust gases in thermal power stations, and also in cement industry, and also in electrostatic painting. Electrostatic painting is a process of using the electric field to apply paint to metals and various types of plastic by giving the object to be painted a negative charge. Here, negatively charged item or object, and giving a paint a positive charge. The attraction is created and the result is a durable, smooth, hard paint on the metal. So this is a principal operation of electrostatic painting. So high voltage DC is only used in electrostatic painting here. Also, high voltage DC is used in communications electronics like TV and broadcasting stations. Also, it's required to charge the units of impulse generators. High voltage DC is the first step in impulse generator to produce high impulse voltage, and this point will be explained clearly in the lectures of impulse voltage and how to produce the impulse voltage. Also, high voltage DC is used for high voltage DC transmission over long distances, and this is one of the important applications of using high voltage DC, is that high voltage DC can be used in high voltage DC transmission over long distances, as it has many advantages over high voltage AC transmission. So what are the advantages of high voltage DC transmission? The first advantage is for interconnection between two power grids or countries with different frequencies. If two countries having different frequencies, let's say this is the first country and this is the second country, and they want to interconnect between each others, this must be done at high voltage DC transmission like here. Also for interconnection of weak power grids to enhance their stability. When high voltage DC transmission is used, the power system stability and the transmission stability increases. For increasing the transmission capacity of existing rights of way by changing from AC to DC transmission system. Any transmission line has its right of way for persons and humans protection. As transmission capacity increases, its right of way also increases. So, for the same right of way, we can increase the transmission capacity of high voltage DC transmission compared to AC transmission. No requirement for reactive power compensation, as in high voltage DC transmission, no reactive power is produced. Also, the main advantage and the fourth advantage for using high voltage DC transmission, that's used for economical transmission of bulk power over long distances. Here, economical transmission. How is that? Let's say if we use transmission voltage 800 kilovolts, like here. If we use AC transmission, in this case, we will use two towers and the width of the transmission will be 320 feet, as we see. But if we use DC voltage and the transmission voltage is bipolar 800 kilovolt, in this case, we will use one transmission tower and the width of the tower will be 130 feet. So here the cost of the transmission is absolutely decreased in case of high voltage DC transmission. So that means economical transmission in case of high voltage DC over long distances. Also, another advantage for power transmission across the sea when the cable length is very long, like that, for long distances when the cable length is very long. So these are the advantages of using high voltage DC transmission over high voltage AC transmission. Let's see how to generate high voltage DC. It can be done by two basic methods. The first method is using electrostatic generator like Van de Graaff generator to produce high voltage DC. Another method is using rectifier circuits or rectifiers. Rectifier circuit can be half-wave rectifier or full-wave rectifier using center-tapped transformer, or full-wave rectifier by using the bridge circuit, or using Cockcroft-Walton circuit, which can be voltage doubler or voltage multiplier. So in the next lectures we will see each method of these types for producing high voltage DC. Thank you and see you in the next lectures.